So now we're going to move into section 4.3, where we're going to be talking about ratios in right triangles. That is, we're going to be looking at something like this picture here, where we're trying to talk about the relationships between those side lengths, the angles in there, not the right angle though, because, well, that one's not as interesting, and the trig functions, where in particular we have a fairly, hopefully, well-known set of relationships that if we want to take sine of some angle theta, that is the length of the side opposite of theta divided by the hypotenuse. So on that kind of picture, that would be A over C. While cosine is the length of adjacent divided by the length of the hypotenuse, so B over C, and tangent of theta is opposite over adjacent, which there would be A over B. And this is where you get the mnemonic, I think it would be an acronym, but not really, it's close enough. So katoa, opposite over hypotenuse for sine, adjacent over hypotenuse for cosine, and opposite over adjacent for tangent. Meanwhile, for the reciprocals, cosecant is just sine flipped over, so it is hypotenuse over opposite, C over A. Secant is cosine flipped over, so that would be hypotenuse over adjacent of theta, C over B, and then cotangent is tangent flipped over, so that is adjacent over opposite, B over A, and I suppose if you want to, you can think of your own mnemonic, but unfortunately, Cho Sha Kao never quite caught on in the same way that SOHCAHTOA did. Also because we don't use those reciprocals quite as much for the way that we define them, even though I'd argue secant's a pretty important one. But anyway, those are 6 main relationships where what we can do with that is use it, in a sense, to solve the side lengths of a right triangle. So if we have a picture like so here, the given right triangle, where we want to be able to find sine, cosine, tangent, cosecant, secant, and cotangent, the 6 trig functions in terms of it. Well, what we can do is first recognize there that we're missing the hypotenuse length, but we're going to jump a little bit ahead to talk about the Pythagorean theorem, at least hint at it, hopefully remember what it is, and use the Pythagorean theorem to get that our third side, C, will have a length of 13 unitless measurements. But I'll leave that to you to verify. In any case, we have that C is 13. So if we want to find our trig functions for sine, it is opposite over hypotenuse. So opposite of A would be 5 over hypotenuse, 13. Cosecant, hypotenuse over opposite, would be 13 over 5. You just flip over sine. Cosine would be adjacent over hypotenuse, so adjacent of A is 12 over 13. Secant would be that flipped over, 13 over 12, hypotenuse over adjacent, while tangent would be opposite over adjacent, 5/12, and cotangent is adjacent over opposite for 12/5. And it is important to mention here that when we're talking about these trig relationships, we always talk about them in terms of a specific angle. If we changed our frame of reference for that guy up there and instead talked about all of these functions in terms of B, we'd get some radically different values from the functions. But here we're looking at A. So just be mindful of that opposite and adjacent type of connection is very, very narrowly determined by which angle we look at. But next, we're going to take this a little bit further and get some more general ideas for what happens at special angles in terms of right triangles.